Hello dear students, welcome to the first session of class 12 chemistry. In this session, we'll be discussing some important topics of your chapter 2. The first topic of discussion is Raoult's law. Raoult's law, as you can see here, it basically gives a relationship between the vapor pressure of a component in a solution and the mole fraction. Mole fraction is denoted with X. In general, we can say that Raoult's law states that the vapor pressure of any volatile component in a solution is proportional to the mole fraction in the solution. So, volatile means those substances which evaporates easily. So, here the vapor pressure of any component in a solution is proportional to the mole fraction in the solution. So, suppose we are taking two components A and B. So, mole fraction is denoted by XA as I told. So, whenever we have a proportional term, we always need a proportionality constant. So, in this case, the proportionality constant is PA naught. Suppose we have two components A and B. So, the component A will be proportional to the just as I have written here, the vapor pressure is proportional to the mole fraction. So, PA naught is the proportionality constant. So, for component A and B, the equation is given as PA is equal to PA naught XA, and for component B, it is given as PB is equal to PB naught XA. So, from here, PA naught and PB naught are the proportionality constant, and it is seen that this proportionality constant PA is equal to the vapor pressure of the component in its pure form. Same goes for PB naught. PB naught is found to be equal to the vapor pressure of the component B in its pure form. So we can say that PA naught is the vapor pressure of the pure component A, and PB naught is the vapor pressure of the component B, which is in its pure form. So this is all about Raoult's law, which is very simple, but it is one of the most important topic. With the help of this Raoult's law, we'll be easily able to define ideal and non-ideal solution. Now let us discuss about what is ideal and non-ideal solution. As you can see, it is written here, ideal solution are those which obeys Raoult's law, whereas non-ideal solution are those which does not obey Raoult's law. Now let us see ideal and non-ideal solution one by one. Let us discuss first ideal solution in details. As you can see here, ideal solution obeys Raoult's law. So, since it obeys Raoult's law, it will also follow this same equation, that is PA is equal to PA naught XA, PB is equal to PB naught XB. Now, when we are talking about ideal solution, we'll be basically talking about solute and solvent. Before we proceed further, let's be clear about what is a solute and solvent. Suppose you are asked to make a sugar solution. You will take 1 spoon of sugar and 1 glass of water. The component which is in lesser quantity, it is known as your solute, and the component which is in larger quantity is known as solvent. So, sugar will be the solute and your water will be the solvent here. And we also know that solute plus solvent gives a solution. Now suppose if we have solute A, we are representing solute as A and solvent as B. Now there will be some interaction between before this solvent and solute mix together with each other. The solvent itself will have some interaction with its own molecule, and the solute will also have interaction with its own molecule. So let us see one example in order to clarify the statement. Suppose if we have a solute NaCl. and the solvent we have water. Now in order to form NaCl, Na must come and interact with Cl, and Cl must also come and interact with Na. If they are not interacting, that means that NaCl molecule cannot be formed. They have some interaction between themselves, that is why they are forming NaCl. Since we are indicating NaCl solute with B, so we can say that NaCl will have a BB interaction. In the same way, water, before it forms H2O, hydrogen must go and interact with water. If they do not interact, they are not going to form the water molecule. So the interaction between this water molecule can be denoted as AA interaction. Now suppose NaCl is mixed in water. NaCl we are denoting as B, and solvent water we are indicating as A. Now when we mix NaCl in water, this NaCl molecule will go and interact with water. So this interaction, we can say that its interaction is AB interaction. NaCl interaction is BB interaction. Hydrogen-oxygen interaction in water is indicated as AA interaction, and NaCl and water interaction is indicated as AB interaction. So we can see here is that AA interaction is known as the solvent-solvent interaction. BB interaction is known as the solute-solute interaction, and your AB interaction is known as the solvent-solvent interaction. And in case of ideal solution, the solvent-solvent interaction, the solute-solute interaction, and the solvent-solute interaction, they are all the same. That means the intermolecular force between all these interactions are the same. So ideal solution obeys Raoult's law, which has all the interaction, either it may be AB, BB or AA, all the interaction are same, and for ideal solution also the same equation can be written. Now coming to non-ideal solution. As discussed, non-ideal solution does not obey Raoult's law. So since it does not obey Raoult's law, it gives two deviations, which are negative deviation and positive deviation. Now negative and positive deviation from what? Obviously it will be from Raoult's law. Negative deviation from Raoult's law and positive deviation from Raoult's law. So here in ideal solution we saw that all the interactions are the same. But here we get two cases. Let us see the first case, that is, now I'm sure you will know what is AB interaction, BB interaction and AA interaction. So I'll be directly denoting them with their letters. For the first one, let's say that the AB interaction. The solvent-solute interaction. If the solvent-solute interaction is stronger than your BB and AA interaction, just suppose that this solvent-solute interaction is much stronger than the solvent-solvent and solute-solute interaction. In this case, there will be less chances that the molecule will go to the vapor form. That means lesser molecule will be vaporized. The chances of molecule going to the vapor phase will be very less. Since the chances of vapor going to the vapor, the chances of these molecules going to the vapor phase will be very less. That means the vapor pressure will decrease. Since the vapor pressure will decrease, the partial pressure becomes lesser. So the total partial pressure will be lesser than the actual vapor pressure. That means, what does negative deviation means? Negative deviation means that the total vapor pressure will be lesser than the expected vapor pressure. We can see that here the total vapor pressure is lesser than the expected vapor pressure. Now let us see for the positive deviation. In the negative deviation, we saw that the AB interaction is much more stronger than the BB and AA interaction. So the positive deviation, let us assume that the AB interaction is very weak as compared to BB and AA interaction. In this case, since AB interaction is weaker, more molecules will have chances to go to the vapor phase. And just imagine if more molecules will have chances to go to the vapor phase, that means the vapor pressure will increase tremendously. So here the vapor pressure becomes greater than the actual vapor pressure. That means, see here, the total vapor pressure will be greater than the actual vapor pressure. So the positive deviation simply means that the total vapor pressure of the system or the solution will be more than the expected vapor pressure. So this was all about Raoult's law, ideal solution and non-ideal solution. By now, I'm sure you'll be little clear about what is Raoult's law, ideal solution and non-ideal solution. If you have any confusion, you can also drop down in the chat box or you can message me personally. In the next session, we will discuss about colligative property and the four colligative property. Before we move to the next session, I will just give a brief introduction about what colligative property is. There are certain properties of a solution which depends only on the number of moles of solute and not on the nature of the solution. Such property of solution is known as colligative property. In our next session, we will discuss about the four colligative property. Still then, you have to wait patiently, stay tuned, take care. Thank you.